Solving logarithmic equations is a method we use when we want to find powers. So this video is going to look into when the unknown occurs more than once in your equation. So one example is when you have 2 times 3 to the power of x is equal to 5 times 2 to the power of x. And you solve it just like you would solve the simple equations where the exponent is unknown. So we're going to follow the same procedure where we're going to log both sides of the equation. So take the log of both sides, and then we can use the laws of logarithms. Remember that if you're multiplying an x and a y inside, then you're actually adding them together. So that's what we're going to do here. So we have log of 2 plus log of 3x equals to log of 5 plus log of 2 to the power of x. And then again use another law of logarithm where the x becomes a coefficient. So we have log of 2 plus x log of 3 and log of 5 plus x log of 2. That's mainly why we use logs, is because dealing with a power, solving equations with powers is not something we could do very simply, but as soon as x comes down here as a coefficient or as an expression here as a variable, not a power, as a base, then it's easier to solve because we know how to solve these linear equations. And the only way that would happen is if we log our expression, because log would force this power of x to come down as a coefficient. So just to explain why we're doing all of this. So you want to find x, you want to end up with x equals to something. So your first instinct has to be, well, to bring all the x's together. So you have x log of 3 minus x log of 2. And then bring the other variables that don't have an x in them together. Factorize an x out, so always try and use this method. You'll always end up using this method whenever you have x's separated and not together. You'll end up bringing them together and then you have to factorize x out, so it's not an unusual method to use. And then you have log of 5 minus log of 2. And then to get rid of this, just divide both sides. So you have log of 5 minus log of 2 divided by log of 3 minus log of 2. And just plug this into your calculator, you will get 2.26. That's the 3 significant figures. So a bit of a different example. If I have e to the power of 2x minus 3e to the power of x plus 2 equals to 0. Now, you can try and solve it using ln, or you can log the expressions. What wouldn't work is that if you can't log them individually, so you'd have to log the whole thing, and there is no rule that would tell you, well, x plus y, well, it doesn't tell you what to do with that. So what you should notice from here, though, is that you have e to the power of 2x and then e to the power of x and then nothing. This can be converted to a quadratic expression, which is a technique, just like the previous slide. This is a technique that you would want to use. So the technique of factorization is something important, and the technique of possibly changing this to a quadratic is important as well. So let's say x, let's not use x, let's use m. Let's say m is equal to your e of x. So it means m squared is equal to e of 2x. So now I can rewrite this as a quadratic. So this will be m squared minus 3m plus 2. And there you go. It's a quadratic that you can actually factorize. So you can rewrite it as such, or if you're comfortable with using e and knowing that it's a quadratic, you can. So if I factorize this, I'm going to get an m minus 1 m minus 2 equals to 0, and then this is either m equals to 1 or m equals to 2. But we haven't solved it. We know that m is equal to e of x. So this or this. Now you can either immediately spot what the x is going to be, but I'm going to actually go through the logging. This is where we can actually log. So I'm going to log both sides. Again, this is a very longer step to go through, but just to explain where the numbers are coming from. And then I have log of 2. Or let's not use log. As soon as you have an e, use a ln, or you can use a log with a base e, so it's the same thing. So I can bring the x as a coefficient, then I have ln of e, and then ln of 1, and then again x as a coefficient, ln of e, and then ln of 2. And you should know that ln of e is just 1. Because remember, ln of e is basically log of base e to e, and anything with the same base and arguments is just equal to 1. So this is ln of 1, and we again have x is equal to ln of 2, and you should know that ln of 1 is 0. So this was covered already. And x is equal to ln of 2. You can find the value of this if you want to, which is 0.693. That's the 3 significant figures. So either x is equal to 0 or x is equal to ln of 2, and that's the solution. And do check your answer from the beginning if you want to. So this is another technique to use when you want to solve these questions. Try to see how you could have gone from here to here. First noting that anything to the power of 0 would be equal to 1, so that should be a clue. And then maybe try to see how we could have jumped from here to the end without these mid steps. So if we try a worded problem this time, so we have a radius of a fungus tree given by a function here. Just to rewrite it in a bigger font, so this is kt. T is time, days since it was observed. So for part A, they just want the initial radius. So initial is when t is always equal to 0. So r of 0 would be equal to 2.4 k times 0. And so this is 2.4 to the power of 0. Anything to the power of 0 is 1, so 5 times 1 is just 5 centimeters. For part B, they're telling you that after 4 days, the radius is 8 centimeters. So r of 4 is equal to 8. And you need to find the value of k. So k is a constant that we need to find. So r of 4 is 2.4 k times 4. But we know what r of 4 is. It's 8. So this is 4k. What you want to do is get this on its own, so maybe simplify the expression, so just have an 8 divided by 5, and that will give you 1.6. So your goal is to get to this expression on its own, so nothing as a coefficient here. So now we can actually apply rules of log. Or just apply log to both sides. So I have log of 1.6 and log of this. And again, using rules of log, this becomes a coefficient. So now I got my unknown as a coefficient. And then you make k the subject. So I have log of 1.6 divided by log of 2.4 equals to 4k. And then you're multiplying by 4 here, so when you move it there, you're going to divide by 4, which is a multiply by 1 over 4. And 2.4 This will give you k, and just plugging it into your calculator, it should give you k equals to 0.13, that's the 134. That's 3 significant figures. So that's you finding k. Again, going back to log rules, so we have k equals to so k is equal to 0.134. For part C, we need to know how long, so we're missing t. It would take for the radius of the fungus to be 10 centimeters. So we want to know when will this be 10 centimeters. So we have 10, 5, 2.4, we have 0.134 times t. And again, we're missing a power, so we're going to apply the same thing. I'm not going to go through the details, so hopefully you can follow through what's happening. I made the first mistake, which is I first need to simplify the 5. So 10 divided by 5, that will give me a 2. So I have 2.4, 0.134 t, and then I can apply the log. Log of 2, I'm just going to bring this as a coefficient from the beginning. Log of 2.4, and then make t the subject. And then divide by this number. So I have 1 over 0.134 times log of 2, log of 2.4. And just plug this into the calculator. It should give you that t is equal to 5.90 days. That's the 3 significant figures. And do put this into the original function to check that you actually get 10 centimeters.